Hi guys, welcome to my channel. I'm making this video for final conveying my best wishes to all of you for your exam tomorrow. Hope you're prepared well. And I'm giving you some instructions, a checklist of what all things you need to do for your exam before you report tomorrow. And as well, today, just give one look to all the important guest questions. If you've done all those, the expected questions for tomorrow. So let us, without wasting any time, let us proceed further with first a few instructions and then some questions from each chapter. If you've already done, fine. If you've not, go through the answers from the book, all related to NCERT. Yeah, so here are some instructions. Please carry your ID card, admit card, and keep a photocopy of admit card at home, a transparent writing board, a transparent stationery kit, scale, pencil, eraser, and pens. And do carry extra pens for the exam. And please make sure that you don't carry new pens. Carry slightly used pens so that you're sure those pens work. Sometimes when you buy a new pen, they are blocked or they don't work during the exam time. So make sure that your pens are used. So the ones which you were already working at home, carry those pens. Go in proper school uniform so that there is no time wastage for arguments, and do not strictly carry any digital devices like watch, etc. Do not attempt cheating whatsoever. It is just not worth taking the risk in return for gaining 1 or 2 extra marks. Do not attempt cheating, do not carry any written material with you, and do not discuss with your friends just before the exam. This will help you to keep your cool. Otherwise, you can get demotivated by discussing, and last moment, you cannot do anything. Have confidence, you've already done your best, so everything is going to be fine. Go with confidence. In the examination hall, children, read the instructions carefully in the first few minutes. The time where you're provided extra time to read the instructions. During this time, you also mark with pencil the questions that you will answer out of the given internal choices. Underline with the pencil keywords like specifically like a question needs increasing order or decreasing order. These are common mistakes that you make, and attempt all questions. There will only be an internal choice. So, and avoid over attempting. Write very neatly, legibly, leave 1 or 2 lines after every question, and see that you are not creating a mess, right? A good handwriting always leaves a good impression on the examiner, and it helps you to catch up an extra half mark or so. Wherever there's a dilemma, whether to give half or not to give half, you gain if you have a good impression on the examiner through your neat attempt. So make sure that your attempt is very neat, and don't use any colored pens like red, blue, green. Avoid using those pens, just use blue pen and underline with that only. Uh, the various chapters that you were supposed to prepare are these 7 chapters. And the important questions is check whether you have covered up all these questions. Electrochemistry, one of the important questions is which conducts more metal at a lower or higher temperature. So this question relates to conduction of metals with temperature. This is conduction of electrolytic conductors with temperature, and this is electrolytic conduction by weak electrolytes. This is strong electrolyte, weak electrolyte, and metals. And the question can be asked directly as what is the effect of temperature on metallic conduction, on electrolytic conduction, and conduction of strong or weak electrolytes. Make sure you've revised this. Then these formulas. This formula can be asked as a 1 mark question or can be asked in the form of a numerical. And then a relation between specific conductance, conductance, and cell constant. Then delta G equal to minus NFE. These are the 3 important formulas that you need to know. Then variation in lambda M with dilution for strong and weak electrolyte. This is one of the very important subjective questions that can be asked, a 3 marks question, where you need to explain the effect with the graph, these graphs. So make sure you revise this. And then the next important topic is Nernst equation. Nernst equation, all the questions, the common mistakes that you make, E cell is equal to E naught cell minus 0.059 upon N log of products upon reactants raised to the power equal to stoichiometric coefficient. So you children generally tend to miss on this term. So please be careful as well as practice this part. You can freshly revise this. Products of electrolysis. I just uploaded a video on electrolysis. If you've not already seen this, you can just keep in mind. I don't know, my intuitive sense says this is one of the important ones that can be asked. Aqueous copper chloride using platinum electrodes or electrolysis of dilute sulfuric acid. So just quickly revise the products of electrolysis, either from the book or you can use the video that I uploaded. For kinetics, the important questions are differentiate between order and molecularity, then derivation of the integrated rate law expression for first order, and dependence of half-life period on concentration for each of these. Then all the graph-based questions, the graphs of log K versus T, or concentration versus temperature, concentration versus, time, rate versus time, all these graphs you should do, all the graph based. Then the next important questions are, children, this type of question is very important. Like the question says 2 moles of A plus B to give 3 moles of C. And let us say I give you that rate of disappearance of A is 0.2 mole per liter per second, right? Or let us say I tell you that the concentration of A changes by this much in a given time. Anything of this kind is given, and you're asked to calculate rate of appearance of C. So just be careful. One point that I want to mention here, that rate is equal to minus half dA by dt is equal to minus dB by dt is equal to 1 by 3 dC by dt. Very, very important. Out of which rate of disappearance of A, rate of disappearance of A is given only by this much part, minus dA by dt, which in this question is given 0.2. Rate of disappearance of B is going to be minus dB by dt. Rate of appearance of C is going to be 1 by, is going to be dC by dt, right? So now you have to compare. This much part is given to us, and you've been asked to calculate rate of appearance of C, means you have to calculate this much. So what are you going to do? You are going to write dC by dt. Rate of appearance of C means dC by dt. Take this 3 to this side. So this is going to be equal to 3 by 2 dA by dt, which is equal to 0.2. Minus dA by dt is this much part. So this 3 comes here. So 3 by 2 times of rate of disappearance of A is rate of appearance of C. So 3 by 2 into 0.2 is going to give you your answer. Okay. Rate of disappearance of A, appearance of C. Similarly, if I had asked you rate of reaction, the rate of reaction is going to be minus 1 by 2 dA by dt. Clear? This is one important kind of question. So then the next important questions can be, they can give you the value of K. Let us say the value of K is given as 0.2 second inverse. They ask you the order. So you know you have to identify order based on the unit. So units of K for each of the order reactions, revise that. And finally, the question where you do concentration of 1 or 2 components is doubled, rate becomes 4 times or 6 times. What is the order of the reaction? Okay, these kind of questions are important when it comes to kinetics. Then coming to surface chemistry, derive Freundlich's adsorption isotherm, write a note on associated colloids, multimolecular and macromolecular colloids, and multimolecular, macromolecular colloids. All these you have to write in brief one line about the explanation, and even if not asked, an example is mandatory to be quoted. Similarly, differentiate between lyophobic and lyophilic colloids. At least 4 differences you should have in mind. Define peptidization, zeta potential, Brownian motion. So Brownian motion, they can also ask you what is the cause and what is the consequence of Brownian motion. Then questions related to charge on colloidal solutions and Hardy-Schulze rule, specifically section 5.4.6, fifth part of NCERT, which deals with all about charge, zeta potential, and Hardy-Schulze rule. Okay, the ferric hydroxide, ferric chloride examples. All these are important questions from this chapter. Then alum, ferric chloride as a styptic. Why? Hardening of leather. What is the phenomena? Coagulation. Colloidal medicines are more effective. Why? Because of more surface area. So these are some important questions that may be asked. Then what is the reason for charge on salt particles? As I dealt with you, charge on salt particles is one of the very important questions of this chapter. Presence of equal and similar charges on colloidal particles provides stability. Why a negatively charged salt is obtained on adding silver nitrate solution to Ki? And any one method for coagulation of lyophobic salts out of Ki or K2SO4, which electrolyte is better in the coagulation of positive salt? This is based on Hardy-Schulze rule. So all these questions are important from surface chemistry chapter. So this is also related to the page I've told you, where charges are explained, positively and negatively charged souls are explained. This is again a very important and common conclusion which can be asked in the form of any kind of question. Okay, so then next is D and F block elements. For D and F block elements, questions related to variable oxidation states, colored compounds, alloy formation, catalytic properties. Then why zinc has lowest enthalpy of atomization, why transition metals have high melting points, why cations are colored, and which of the following are paramagnetic, which are not. These are the charges, children. These are charges. So zirconium and hafnium have almost identical radii. And then E naught value for this couple is positive, whereas that of chromium is negative. These are a few important questions. Anything closer to this, similar to this, can be asked. Make sure that you know these answers. Write down IUPAC name of this or any such compound. Similarly, write IUPAC names. Just revise the rules of IUPAC name, where you have to put 8 and where it can, all those things. And then formula of this structure. Structure is given, a name is given, write the structure, or structure is given, write the name, either of the two. Then very important question is hybridization, magnetic behavior, and shape. For this, you should know all the examples, at least in NCERT chapter and the exercise. Then on the basis of crystal field theory, write the electronic configuration, that is T2G EG concept, and which is more delta O or pairing energy. So comparison of these two, all the questions based on that. And drawing the crystal field theory figure, crystal field splitting energy diagram for tetrahedral and octahedral complexes. So these are the important topics for coordination. Aldehydes, ketones, and carboxylic acids, very important. Compare the reactivity. This question can be asked as reactivity towards nucleophilic addition reactions, or reactivity towards HCN, or reactivity towards ammonia derivatives, or reactivity towards sodium bisulfite. Like this can be asked in any way, either in general or towards a particular kind of reagent. So what you have to remember is all aldehydes are more reactive than all ketones. If it's a subjective 2 or 3 marks question, you have to give two headings: plus I effect and steric factors. More plus I of alkyl groups, less reactivity, and more steric effects, less reactivity. So one common confusion that children have that I want to clarify: formaldehyde is more reactive than all aldehydes, and all aldehydes are reactive than ketones. For example, if we had benzaldehyde, so benzaldehyde is going to be more reactive than acetone, and all aliphatic ketones are more reactive than aromatic ketones. This is one common mistake that you children make: comparison between benzaldehyde and acetone. You generally have a confusion between these two, so just be careful. All aldehydes, whether aliphatic or aromatic, are more reactive than all ketones. So then is comparison of these acids. So you know the factors: releasing groups decrease and withdrawing groups increase, and then there's ortho effect. So just revise this topic, and then distinguish between aldehydes, ketones, and acids. For this, you need to know iodoform test, you need to know Fehling, Tollens, and then DNP test. DNP test, for example, if I ask you a question to compare between ketone, or let us say, give a comparison between propanol propanol, let us suppose propanol and ketone, this ketone. So none of these gives iodoform test, right? Ketones don't give Fehling-Tollin. So which test are you going to use? You're going to use the DNP test. DNP test will be shown by ketones, but not by alcohols. So all the distinction pairs, important distinction pairs between aldehydes and ketones. Aldehydes and ketones can be distinguished using Fehling and Tollin. Fehling-Tollin given by aldehydes, not by ketones. And for acids, which tests you will relate? For this sodium bicarbonate test, brisk effervescence with sodium bicarbonate for acids and not for aldehydes or ketones. Clear? Then we have very, very important, everything related to aldol. What is aldol? Mechanism of aldol, what kind of substances give, why acidic hydrogen, crossed aldol products, all those things revised freshly. Cannizzaro reaction, reaction with HCN, with ammonia derivatives, Rosenmund's reduction. These are some important reactions. Even decarboxylation. These are some important reactions which can be asked. No one can ever be sure of what will be asked. I'm just giving you the closest guess. I hope some of these help you. So IUPAC names of any of the structures given in NCRT. This is one of the previous year question. IUPAC name of isobutyraldehyde. So what is isobutyraldehyde? Isobutyraldehyde is 2-methyl-propanol. So this way any structure can be asked. And aromatic acids do not undergo Friedel-Crafts reactions, do this. And then all the conversions related to this chapter. And finally, we have amines. Under amines, you're going to take up, arrange the following in increasing order of the basic strength. So you must know with thoroughness comparison between primary, secondary, tertiary amines, the methylamines, the ethylamines. Please do not ignore this question. This can be asked in any way. So do this question well. And then give a chemical test to distinguish between primary, secondary, tertiary amines, aliphatic and aromatic amines. This you must compare. Okay, this is N-methyl aniline, aniline and benzylamine. So these are just some common pairs that can be asked. And Hinsberg test, Hinsberg reaction can be asked conceptually, can be asked in the form of a distinction pair. So this is also important. Name of the reagent, benzene sulfonyl chloride. All these are the important questions. I hope this helps, children. All the best. Go with positivity. Have a good night's sleep. Sleep on time. And go with confidence. Whatever you could do, you've done. So rest, let it be in God's hands. You go and with a fresh mind, relaxed mind, attempt your papers. And even if you find the question paper difficult on first reading, have patience. Give it a second reading, children. Give it a patient reading. So you get enough time in the beginning to go through the paper. Don't waste that time. Actually go through that with pencil. You can mark the questions you would want to attempt. So do everything in a systematic manner. All the best. May God bless you all. Go and rock. So here are a few conversions from amines chapter. A very quick review on these. Nitrobenzene to benzoic acid. Nitrobenzene treated with a reducing agent such as 10HCl, it will convert to aniline. Sodium nitrite HCl. Diazonium salt with copper cyanide and KCl, you get cyano. And dilute acid gives you benzoic acid. Dilute acid gives benzoic. And if you had used here concentrated acid, that would lead to partial hydrolysis, and you're going to get conversion of amide. So remember this is one of the common conversions that can be asked. Then benzene to metabromophenol. So benzene, again nitration, nitrobenzene with bromine iron dark, we get metabromo. 10HCl converts nitro to aniline. Just remember nitro group to NH2 group can be done with 10HCl. And then with sodium nitrite and HCl or HNO2, we can convert to diazonium. And diazonium, from diazonium, there are so many pathways to convert to phenol, to chlorobenzene, and so on. So use dilute acid. This gets hydrolyzed to give phenol. Then next we have benzoic acid to aniline. Benzoic acid to aniline. Here we have benzoic acid treated with PCl3 or PCl5 or SOCl2, any of these reagents, we get benzoyl chloride with ammonia amide. HCl will be lost. And this is Hoffman bromamide. with bromine sodium hydroxide, we get aniline. So in case you use lithium aluminum hydride, you get amine with the same number of carbon atoms. These are three important conversions. Then aniline to 2,4,6 tribromofluorobenzene. This can be done with aniline treated with bromine water, gives us the tribromo derivative with nitrous acid disonium, and treated with HbF4, the disonium salt, disonium part gets replaced with fluoro. The next one is benzyl chloride to phenylethanamine. Benzyl chloride to 2-phenylethanamine. This can be done with benzyl chloride with KCN. Cl gets replaced with cyanide. If you treat it with concentrated acid, this gets partially reduced. This is partially hydrolyzed to amide, and with bromine sodium hydroxide, we get 1 carbon less amine. And if we treat it with lithium aluminum hydride, we're going to get the amine. So basically, these are 3-4 reagents that you can keep in mind. Your conversions related to amines chapter will be managed with these reagents. So benzene to phenyl cyanide or benzene to benzyl cyanide, benzene to nitro, then to aniline, then to disonium, and then to cyano. And benzene with Friedel-Crafts alkylation methyl chloride gives toluene. With chlorine H nu, we get side chain substitution. With KCN, we get cyano. So these are some important conversions of amines chapter. And these are some important conversions for aldehydes and ketones acids chapter. Ethanol to propanol. Ethanol with sodium borohydride, a reducing agent, we get ethanol. Phosphorus iodine converts to iodo with cyanide. This Ci bond converts to cyanide. Complete hydrolysis with dilute acid gives acid. Reduction, alcohol, and PCC to aldehyde. Ethanol to acetone. Ethanol with Grignard reagent. Grignard reagent is also an important reaction. With Grignard reagent, we are going to have this going here, methyl coming here, and we get formation of this product. This on hydrolysis gives us a secondary alcohol, which with PCC gives ketone. Ethanol to lactic acid. Ethanol with HCN gives us acetaldehyde cyanohydrin. Complete hydrolysis converts the cyanide to acid. So this hydroxy acid corresponding to ethanol, this is called lactic acid. Then ethanol to ethanamine. Ethanol to ethanamine. First treated with ammonia. First treat ethanol with ammonia. We're going to get an imine, which on reduction gives amine. Ethanol to 3-hydroxybutanol. We have almost doubling of carbons. That means aldol condensation. This is aldol condensation done with dilute sodium hydroxide. 3-hydroxybutanol to butane 2-ol. This is reduction. Carbonyl converted to CH3 using Wolff-Kishner reduction. Hydrazine and KOH and glycol. And then next is protonaldehyde, that is butanol to butanol. So here we are using protonaldehyde, that is butanol with hydrogen nickel. High temperature pressure, we are going to get alcohol. Both double bond and aldehyde get reduced with this reagent. With Tollens reagent, only CHO, which is easily oxidizable, gets oxidized to COH. This is a weak oxidizing agent, hence oxidizes only aldehyde to acid. So we could have used Fellings also for this purpose. So these are some important conversions for acids chapter. Now, if you want to convert sodium propanoate to ethane, that means this group needs to be removed. We are going to use soda lime decarboxylation. And if this is to be converted to butane, then Kolb's electrolysis. What in general does Kolb's electrolysis do? Kolb's electrolysis, if I generalize this, children, then Kolb's electrolysis converts RCOONA to RR with Kolb's electrolysis. Just keep this much in mind, RR. And with soda lime decarboxylation, we are going to get RH. So which means if I'm starting with this compound, this much part is R. So here I'm getting RH and here I'm getting RR. This is R and this is coming from another R. So these are the important conversions. Hope this helps.